If this is your first time here, make sure you hit that subscribe button, turn on your notification, and give us the thumbs up.
We're gonna discover the process discrete alarm object that is part of this library. So the file is open. We're gonna have here a PLC, also an HMI. So let's look at the PLC first. And this is just a sample program, so you can change the PLC to the one you have, and IOs and all that stuff. So this will be like perhaps your vanilla program. So under here we have just one program. It's kind of layout based on those objects. So the first one I'm going to play with is the discrete alarm. So let's have a look at that. So in here we already have the block added, and it's linked with all the data that it requires. And then this is, for example, let's say a discrete inputs that it's an alarm, could be a level switch or a float switch or some kind of a point that we want to alarm it, so we can add it in here in line with the block. And then there's some parameters that we can configure that we can have a look at. So by default, you have all this stuff set up, so you can, right away load up the program to your PLC and HMI, and you can see, how things interact. And that's what we're gonna do first before we can, add a block here and dig into the parameters. I just wanted to show you guys the functionality. So I'm just gonna go first online with the PLC to basically dump this program. Controller transfer. Okay. So our block is now loaded in the PLC and it's up and running. Next, I'm going to go to the HMI, and I'm going to do the same thing. Now in the HMI here also, you can see here there's some pages. As you will see, there's the faceplate for the discrete alarm, and there's the main, which is the main page, and there's the object we're going to be interacting with from the HMI. This is the object for the discrete alarm. And if we look here, we find the library, the process library, and it's right there, the discrete alarm symbol, and also the faceplate. So let's go line with the HMI. And we're going to download this program as well, so we can see how the discrete alarm object works first before getting under the hood and digging into the parameters. Okay, so our program has been now loaded, and I'm just going to show you guys here I'm running VNC. So we can see that in here, we have some bigger. So this is my object right here. If I click on it, it gives me this faceplate in here. And as you see here, there's this is the tag, basically place where you can put the name of your device, description area, and then the status in here. And there's also an area here for the bypass. Once we set up the block and the parameters, we're going to see all of these things. We could set up this stuff from the HMI or from the PLC. So let's do that from the HMI. We can see we have the tag name here, the description, and also is here, so that's good. The next thing we can set is the debounce for the alarm. So, for example, if the alarm is made to trigger as soon as it happens, then perhaps we can give it here some time before it's in alarm state. So maybe I can put this 2 seconds, for example, if I want. But then notice here that I have the min and max are 0, 0. Now, that is because these parameters are in the PLC, they're not exposed in the HMI for safety purposes. So you can actually set the min and max of the debounce time. So once we set up that, this will be we will be able to basically write our memory. So I'm just going to cancel this for a second. And as we see here, we already have the information we write in HMIs right here. So I can do this to 60 instead. Just make it lowercase instead. And then we have the config debounce max and min. So it's 0, by default it's 0, 0. So if I put this here, let's say, I don't want the alarm to be more than 120 seconds, which is 2 minutes. Then I can put that to 120. Once I do that, if I go back now to my debounce in the HMI, I can see that this is changed. And now I can put this to 2 seconds, for example. So the other thing we can set is the OK state of the input to the alarm. That's about the settings we can do from the HMI standpoint. There's also some other settings we will have to do, or we need to do, from the PLC, and those are not exposed for make this safety reasons, alarm working. We have here this config enable. Now this config enable to enable the alarm or disable it. So we need to put that to true for the alarm to basically trigger and be operational and working. The other settings we have config latch. So if we require the operator, when alarm triggers, he needs to do a reset, even when the alarm goes back to normal, then we need to make this true. Same thing for acknowledge. So for me, I'm gonna put both first and true. You'll notice here we have 2 seconds that we set up from the HMI. And we also have the BIP enable. If I bring here the HMI, this is our bit in here, or parameter that we need to set. So notice here there's nothing in this area, but as soon as I click on here, I have 2 buttons that appear now. So these 2 buttons will give the operator to activate and bypass from the HMI. So it's just a kind of security. If you don't want them to bypass, for example, an alarm, then you can just leave this off, and there will be no way to bypass it from the HMI. Now, once we get this ability, there's a couple things we have to set up. We have the bypass time max and min, which is basically the max and min for your bypass timer. So you have the ability to set up the min and max in there. So it's an extra security for that. You can set it up in the HMI as well, but it's also set up in the PLC. So if you need to change it, you change it across the place, and it's propagated across the system. So I can say, maximum that you can set up the bypass timer to is 30 minutes, no more than that. So the maximum you can put here is 30 minutes. If I try to put more than that, it's not gonna basically let me do that. So if I try, for example, 50, it doesn't let me do that. It's overwriting to 30 right here. So it's already built in the logic. So for us, I'm just going to put this to 30. So now we have 30 minutes for this alarm to bypass it. So if we click on bypass now, I can see here that I am in bypass mode and I have basically 30 minutes left or remaining before this bypass will be removed automatically. Or you can manually remove it from here. So if the operator is done and everything is happy, you can place it back to normal. If not, after 30 minutes, if nothing, if you didn't basically press on reset to gain another 30 minutes, then the bypass is going to be taken off and the alarm is going to be activated. So that's basically for the bypass. Now, once we do enable this, we will notice also that from the object itself, I can see that there is something not right in this object by this little warning triangle that's given me here. So if I click on it, I can follow it and then say, okay, well, I am in bypass, that's why. The other thing that we can basically see here is we have these buttons, then we have a status. So depending on what the status is in here, this will change of this symbol. Right now it's like this because I am in bypass mode. But if I took the bypass out, you can see it's giving me a check mark, which means everything is good, everything is happy. There's no problem. But if I go and trigger my alarm, and basically I'm just going to trigger this alarm, make it true, I can see now the alarm is here after a couple seconds because that's our debounce time. So now the alarm triggered. Now, as the alarm triggered, one of the features that is with the process DA object is the alarm is timestamped in the PLC. So if I click on this button show, it showed me when the alarm has been triggered. So now if I go and say acknowledge, I can see also now the acknowledge time as well. So that has been built in inside the logic itself. Now from the object standpoint, I can see now that the objects become red with a white circle around it, which means that I am in alarm state, and the raw input, which is basically this level switch, is also in the alarm state. So if I go back and in the alarm, I'm just going to make it now false, so I don't have the alarm anymore. However, we can see here that this is still says that the alarm has been acknowledged, but it's still in alarm. And also this is showing me that it's red. But notice now the circle around the object become green. What that means is it means that your alarm is ready for reset. So if I go back to my faceplate now, I can reset, and I know it's going to go back to normal because that's green. So if I go reset, go back to normal, and this go to gray, which is this is the normal status of your basically alarm. So that's a nice feature. The reason for that is, let's say we have an alarm. So it's a couple seconds now. It shows it's an alarm. And then let's say for some reason, the operator need to do some work on this vessel. So for not shutting down some stuff and why not, you need to bypass this. So you can click on the bypass, right? And now we can see it's red, it's in bypass. But for example, when the alarm comes back to normal, let's say now it's false. So that's a good indication to the operator to tell him, hey, if you remove the bypass, nothing will happen. The system will be fine because your alarm or your device is ready to be reset. So you can take your, basically, you can reset and take the bypass off and you'll be fine. So if I do reset first, I can see now that it's become basically gray. And now I can know that if I activate, everything should be fine. I shouldn't be shutting down or anything. And the process will just keep working normally without any interruption. With this, we concluded part 1 for this video, and I will see you shortly in part 2. So let's say, for example, now we want to add a level switch low on this vessel. So we're going to see how we can achieve that. So if we open up our program here, the first thing we're going to do is add the block for it. So I simply just copy and paste this, and I can call this little switch low 1260 in, for example, and then I'll change this to low, and in the same way I modified it. So now that we have our parameters all in there, that's all good from the PLC side. So we'll go to the HMI now. The first thing we want to do in the HMI is we want to map our variable which is created, which is basically this guy right here. So I'm going to say create, and just to keep consistent with everything else, remove this default name and just give the level switch logo. And then next, I'm going to go to our main page, and I can just simply copy and paste this guy, this one here, for example. Double click on that to get the properties, and what I would have to do is change my tag in here, and I can see it now, it's available. And then the next thing I want to do is in the faceplate in here, because we want to use the faceplate, is create a faceplate for the level switch logo. So we can do that by simply go to our template in here, and then just copy and paste. So it's create for us this in here, and then we can rename it to our level switch, for example, and just copy that, and that's the name we want to put in here, just like that. So that's all set, it's all good. Our faceplate, also we have to go in there and do the same thing. So if we go here, we have to change this to our level switch logo. Hit enter, and then we're gonna change this to our faceplate. So that's all set, and that's about it we have to do in terms of the settings. So everything is good to go. Now we can go and dump this to our HMI PLC server. So now that our program is all downloaded to the HMI PLC, I can see here that the level switch has been added to my HMI. So we can go ahead and do a couple of configuration to make it operational and functional. So if we open up that, again, like we mentioned in the beginning of the video, that you can set up all this from the HMI or the PLC. So now that we're okay with the settings in here, we can go to our PLC to complete the configuration. You can do that lots easier. So we're going to set up the enable, the config OK 0, that's fine, and then the latch and acknowledge set up that. My evals min and max, and my duration 0, that's fine. I also want to give the ability to bypass, so I'll set that to enable, and the max time, I'm going to put 120 minutes and 30 for this particular one. So that's all all the settings we have to do here. Now, if I go back to my HMI, I can see that I have the label here. My faceplate is set up with bypass, and everything looks good. So we can test it by simply enabling this to true. I can see that it's in alarm. I can also see that in the HMI as well. So it's all good. I will see also the time that it has been triggered in. So that's about the settings you need to do to add another basically process DA object to your HMI.
If you made it this far, make sure you hit that subscribe button, turn on your notification and give us the thumbs up. And again, thank you for watching.